In this video, I will discuss trigonometric ratios of some standard angles. A triangle is a closed figure formed by three sides. So side 1, second side, and third side like this. So there will be three side lengths A, B, C, and the angles capital A opposite small b, it's capital B angle, and this third angle is angle C. So one of the properties of the triangle is the sum of the angles is 180 degrees. Another property is side and opposite largest angle will be largest. Similarly, side opposite smallest angle will be smallest side. Side length is proportional to the size of the angle opposite it. So if one angle is 90, the remaining is 90 degrees, which will be split between these two. So if one angle is 90 degrees, then that is the maximum angle of the triangle. The other two angles are smaller than this angle. Right angle triangle is a triangle where one of the angles is 90 degrees. So it can be like this. This is 90 degrees. 90 degrees represented like this. This is the third side. Suppose I call this angle as theta. This angle should be 90 minus theta. Because out of 180, 90 has gone here. So the remaining 90 gets split between these two. And sine of an angle is defined. Let me take this angle theta. Sine theta is defined as opposite side. For angle theta, this is opposite side. For angle theta, this is adjacent side. Sine theta is defined as opposite by this hypotenuse. This right angle triangle, so Pythagoras theorem is valid. So this square plus this square equal to this square. And cos of the angle theta is defined as adjacent by hypotenuse. This is the definition. And the third ratio is ratio of these two. So tan of the angle theta is defined as opposite by adjacent. So in this triangle, the maximum length side is the hypotenuse because maximum angle is 90 degrees. So side and opposite the maximum angle is hypotenuse, which is equal to the maximum length. That's according to Pythagoras theorem also, because Pythagoras theorem is this square equal to this square plus this square. So the ratios sine, cos, tan is known for certain standard angles. So these standard values are 30 degrees, 60 degrees, 45 degrees, 0 and 90. So these are the values. But one thing is how to remember these values. So one thing we can realize is we can form a triangle with 30, 60 and 90, because if you add these angles 30 plus 60 is 90 plus 90 plus 90 is 180. So we can have a triangle of those angles. Second triangle that can be formed is 45, 45 and 90. Two angles of value 45 degrees and third angle 90 degrees. We are considering right angle triangle, so one of the angles is always 90. So two standard triangles you can construct. This is the first triangle, 30, 60 and 90. So side opposite 30 degrees will be smallest, so this should be 30 because the minimum side, and this is 60 degrees and this is 90 degrees, the maximum length. And one result we have to remember is the side ratio will be, suppose this length is 1, then this side will be root 3 times 1 and this length will be 2 times 1. Root 3 value is 1.732, so it's between 1 and 2. So the side lengths will be in the ratio 1 is to root 3 is to 2. What is the minimum? Should be opposite 30 degrees. Root 3 is 1.732, it's in between value, so it should be opposite the middle angle, which is 60 degrees, and the maximum angle is 90. So the maximum length side is 2, so it should be 2. Pythagoras theorem we can check. Root 3 square is 3 plus 1 square is 1, that should be equal to 2 square. 4 equal to 4. So even if you remember these two, I can get this thing by the Pythagoras theorem, because this side is this square minus this square and then take the square root. 2 square minus 1 square, that will be root 3. So even if you remember these two, I can get this, calculate that value using Pythagoras theorem. So this one standard triangle, you have to remember this thing, 1, 2, root 3 for angles 30, 60 and 90. Second standard triangle is 45, 45, 90. Two angles are same, so the side opposite those two should be equal. So this is an isosceles triangle, two sides equal, and the third side is the bigger side, that should be opposite the maximum angle 90 degrees. So this is 45, this is also 45. Because out of 90, the remaining 90 should be split between these two. One of them is 45, so the other one should be 45. So here, if this thing is 1, 1, I can get this thing by Pythagoras theorem, 1 square plus 1 square, which is root 2. So the sides are in the ratio 1 is to 1 is to root 2. If you remember this thing, it's good, otherwise you have to get this thing by Pythagoras theorem. Hypotenuse square is a square plus b square. This is c. So c square equal to a square plus b square. From that I can get this 1, 1 root 2 ratio. Third triangle is a special triangle, because I have to understand 0 degrees and 90 degrees also. I have to get sine and cos, everything of 0 degrees, and also all the ratios for 90 degrees. So to get this, I gotta take a triangle like this. So this is 90 degrees. This is a small angle. Small angle is denoted by delta, and this remaining 90, remaining of 90, which is 90 minus delta. For example, this 90, this is 1 degree, and this 89 degrees. So obviously this will be the minimum side. Okay, to get sine 0 degrees, I will find sine delta. Sine delta is this opposite side. Let me call this A, B, C. Sine delta is opposite B by C, and in the limit where delta tends to 0, this is 0. I am pushing delta to the limit 0 because I have to get the values of sine 0 degrees. It's difficult to understand 0 degrees, so I'll try to figure out what is happening with delta and then push that delta to 0 to get the value of sine 0 degrees. So from this I get the result that sine 0 degrees is 0. Similarly, I can get cos 0. Cos, to get it, I'll do delta because I have triangle only for delta. Cos delta is adjacent side A by C, and A and C are approximately equal because this thing is very, very small. So this thing is approximately same. So this is approximately 1, and this is a very good approximation when delta tends to 0. So I have the result cos 0 degrees is 1, and tan delta, you get tan 0 opposite B by adjacent A, and B is very small when delta is very small. So it's approximately 0 in the limit delta tending to 0. So I get the result tan 0 is 0. Similar for 90 degrees. To get the results for 90 degrees, I'll consider this angle. To get sine 90, I'll find sine 90 minus delta. That is opposite side A by C. In the limit, it's approximately 1 when delta tends to 0. So 90 minus delta tends to 90, and this B tends to 0, and A will go become C. So the limit A by C. So A and C are approximately same, but this thing is become very, very small because A and C are almost same. So in the limit they'll be equal. So it's sine 90 is 1. So I get the result sine 90 is 1. Similarly, I get cos 90 is adjacent B by C, which is approximately 0 in the limit delta tending to 0. Because B will become smaller and smaller as delta becomes smaller and smaller. In the limit, I push it to 0. So that becomes cos 90 is 0. Tan 90 opposite A by B. This thing is very, very small. So it's approximately infinite when delta tends to 0. So just I consider the limiting triangle which is made of 0, 90. Instead of 0, I figure out what is delta and then 90 minus delta and then push delta to 0. So I'll get delta will become 0 and 90 minus delta will become 90. So sine delta is 0 or sine 0 is 0, cos 0 is 1, tan 0 is 0, and sine 30, I have to use the triangle 30, 60, 90 triangle, and the length ratios are 1 is to root 3 is to 2. Root 3 is 1.732, so the ratio is 1 is to 1.732 is to 2, and 2 is opposite 90 degrees because 90 is the maximum angle. So from this I get 30 and 60 results. 45, the triangle is 45, 45, 90, the ratio is 1 is to 1 is to root 2. And 90, you have to consider 90 minus delta. And cosecant theta is 1 by sine theta, take the reciprocal of this one. And secant theta is 1 by cos theta, take the reciprocal of this one. And cot theta is 1 by tan theta. So if you remember the three triangles, 30, 60 and 90, and 45, 45, 90, and the special triangle, the limiting triangle of angles delta, 90 minus delta and 90, you can remember these results.